Good morning everyone. In the previous class, we have discussed about exothermic and endothermic reactions. Today we are going to discuss another new concept, that is reversible and irreversible changes or reactions. We see so many changes around us every day in our life. For example, boiling of water, melting of ice, burning of paper, cooking of egg. So these are the changes we see every day in our life. Okay, for suppose if you observe burning of paper, okay, if you burn paper, then it is converted into ash, right? Ash. Okay, paper on burning gives ash. Now tell me, is it possible to convert ash again into paper? Yes, not possible. Ash cannot be converted into paper again. Okay, so this change occurs only in single direction, that is forward direction. Only forward direction, no backward direction takes place. So ash cannot be converted into paper. This change is irreversible change. So finally, what is irreversible change? The change in which move only forward direction, that change is known as irreversible change. So there is no backward direction, only forward direction. So that type of change is known as irreversible change. What about reversible change? Okay, reversible change. For suppose you can take some ice cubes. On melting, what happened? It will be converted into what? Water, right? Water. Okay, melting. Again, freeze water. Then what happened? Again converted into ice cubes, right? Again freeze water. Then what happens? Again water converted into ice cubes. Freezing. So here what happened? Ice cubes converted into water. That direction is forward. So this is forward direction. Again water converted into ice cubes on freezing. This is backward direction. So in this change, what happened? Both forward and backward directions takes place. Okay, so ice cubes to water, water to ice cube. So this type of change is known as reversible change. I think finally you got it. Irreversible change means there is no backward direction, only forward direction. Initial substance we can't get back. That is irreversible. For example, paper on burning gives ash. Again, ash cannot be converted into paper. So no backward direction possible here, only forward direction. That is paper to ash only. Ash cannot be converted into paper again. But reversible change, both the directions possible here, forward and backward. Ice cubes converted into water, that is forward. Again water on freezing gives ice cubes back. Okay, so here we can get back. That's why this reaction is known as reversible reaction or reversible change. Got it? So finally, irreversible means the change or reaction in which move in single direction, that is forward direction, known as irreversible reaction or change. Okay, so there is no backward direction. But in reversible changes, so there is a possibility of backward direction. For example, ice cubes converted into water. Ice cubes on melting gives water. Again water on freezing gives ice cubes back. So here both forward and backward directions possible. So that's why this is reversible change. Let us discuss some examples of irreversible reactions. Example, acid-base neutralization reactions are irreversible reactions. You know, acid combined with base to form salt and water. Example, HCl plus NaOH is gives rise to NaCl plus water. No backward reaction, only forward direction. HCl plus NaOH gives NaCl plus water. H2SO4 plus KOH, K2SO4 plus 2H2O, salt plus water. Acid-base neutralization reactions are irreversible reactions. Next one, precipitation reactions. That means the reactions in which precipitation is formed, precipitate is formed. Those reactions also irreversible. Generally, example, AgNO3 aqueous, NaCl aqueous gives AgCl precipitate plus NaNO3 precipitation reactions. Okay, next one, MgSO4 plus BaCl2, MgSO4 aqueous, BaCl2 aqueous, BaSO4 precipitate, barium sulfate precipitate, down arrow, plus MgCl2. So precipitation reactions are irreversible reactions. Okay, na? Next one. So no backward direction takes place, only single direction. Till the reaction complete, it moves in single direction only. All combustion reactions are irreversible. Okay, combustion of coal, carbon plus O2, which gives rise to CO2. Here we can't get back from CO2 to carbon and O2 again. Okay, carbon burning in O2 gives CO2. Again CO2 cannot get back to carbon and O2. Not possible. Okay, magnesium ribbon, O2, MgO, magnesium oxide. Again MgO cannot get back to magnesium and O2. Okay, so this is all combustion reactions are examples of irreversible reactions. Okay, for example, methane combustion gives CO2 plus water. So all these reactions are irreversible. Okay, and also decomposition of KClO3, potassium chlorate, decomposition of KClO3, potassium chlorate, KCl plus O2. Okay, this is also irreversible. Okay, so all these reactions are examples of irreversible reactions. There is no backward direction takes place. Okay, till end of the reaction moves in single direction only. Okay, so acid base neutralization reactions, precipitation reactions, all combustion reactions, and also decomposition of KClO3. Some more examples for irreversible changes in our daily life. Best example, cooking food is irreversible process. Cooking of any item is irreversible. For example, cooking egg. You can take egg, cook it to omelette. Now tell me, is it possible to get back egg from omelette? Yes, not possible. Similarly, cooking chapati, cooking bhaji, cooking dosa, everything is irreversible. If once we cooked, can't reverse. So cooking food is irreversible process. And also rusting of iron, also irreversible process. You know how rust is formed? You can take one iron rod, pure iron, keep in atmosphere. What happened? It absorbs moisture and oxygen from atmosphere. After some days, a brown color layer is formed on the surface of the iron, known as rust. Okay, so here this is complete, this is permanent process, can't reverse. Okay, so rusting of iron is an example of irreversible process. And also all naturally occurring processes are irreversible. Okay, these are some examples of irreversible processes. Next one, reversible processes, reversible changes. Already we discussed what is reversible change. Reversible change means the change in which both forward and backward directions takes place, known as reversible change or reversible reaction, both forward and backward. For example, melting of ice. Melting of ice is an example of reversible change. You can take some ice cubes, ice cube on melting converted into water, right? Again water on freezing converted into ice cube. So this process is reversible. Okay, so ice cube to water, so this is forward direction. Freezing water to ice cube, backward direction. So this process taking place both forward and backward direction. That's why this is an example of reversible change. Okay, and also boiling of water. Boiling of water also reversible change. H2O, water, liquid, boiling, H2O, gas. Again on cooling gives H2O, liquid, cooling, boiling, nothing but evaporation. H2O, boiling gives H2O gas. Again H2O gas on cooling gives H2O liquid. So this reaction, this process takes place in both forward and backward. That's why this is an example of reversible change. Finally, reversible change or reversible process means the change or reaction in which both forward and backward directions possible. Okay, so that change is known as reversible change. So generally that reversible change denoted like this, double arrow. Reversible change denoted by double arrow. This arrow indicates forward, this arrow indicates backward direction. Okay, so whenever you observe double arrow, you must identify that is a reversible process. Okay, let us discuss some chemical reactions, reversible chemical reactions. Example, N2 plus 3H2 is gives rise to 2NH3. This is forward reaction, this one backward reaction. You know, these are reactants and these are products. In forward reaction, reactants converted into products, right? In backward reaction, products converted into reactants. Okay, next, H2 plus I2 is gives rise to 2HI. Okay, next one, 2SO2 plus O2 is gives rise to 2SO3. 2SO2 plus O2 is gives rise to 2SO3. N2 plus O2 is gives rise to 2NO. These and all reversible processes. Both forward and backward direction takes place. N2 gas, O2 gas, NO gas. All are gases here. SO2 gas, O2 gas, SO3 gas, H2, I2, HI. Okay, N2 gas, H2 gas, NH3 gas. Okay, so these are all examples of reversible changes. How you can identify this is a reversible reaction? Here, double arrow. This arrow indicates forward reaction, this arrow indicates backward reaction. Okay, so finally, reversible change means the reaction in which both forward and backward directions takes place, known as reversible change. Okay.